Hi dear students, welcome to Geeta's classes. In this class, we are going to find out the Laplace transform of some more elementary functions. So in the previous class, we have found out we have defined the function L of f of t for t greater than 0. It is defined only for the functions f of t where t is greater than 0. So by definition it is integral 0 to infinity e power minus st f of t dt. This is the Laplace transform of f of t. And in the previous class we have found out L of k is equal to k by s. Therefore if you substitute k is equal to 1, L of 1 is equal to 1 by s. And L of e power at is equal to 1 by s minus a. And L of e power minus at is equal to 1 by s plus a. I am repeatedly telling all these things because you have to by heart all these functions. You have to remember these functions, okay? Because we have to do the problems, all these things are essential, important. So now let us find out L of t. By definition, in this class we are going to find out L of t and L of t power n. Okay. So first let us find out L of t. It is integral 0 to infinity. By definition it is e power minus st into whatever you have here. That should be written here. So into t dt. So for our convenience let us write t into e power minus st dt so that this can be taken as u and v. You know the formula integral uv into dx is equal to u into v1 minus u dash into v2 plus u double dash into v3 minus etc. where u dash is du by dx, u double dash is d squared u by dx squared and so on, and v1 is integral v dx, v2 is integral v1 dx and so on. Okay. So this is, let us take t as u and e power minus st as v. Okay. This is the first function. This is e power minus st as v. So it is integral u into u. U is what? T. Into integral, just write the function, first function u as it is. And e power minus st you have to integrate. v1. v1 is what? Integral v dx. So e power minus st by minus s you write in the second bracket. And if you want to do it easily, you keep on, first you write the first function in the first bracket and second function v in the integrate and write in the second bracket. Keep on differentiating the first bracket and keep on integrating the second bracket. That is the method. Okay, so keep on differentiating the first function. First function is t. So if you differentiate, it is 1. Again, second bracket you should keep on integrating. So e power minus st. Already we have one minus s and one more minus s will come. So it will become s squared. And next onwards plus 0. So you will not have the remaining. So integral 0 to infinity. So t minus, if you substitute infinity, this will become e power minus infinity. This is also in e power minus infinity. So for upper limit, both the values will become 0. And for lower limit, if you substitute t is equal to 0, it is 0 minus of 1 into e power 0 by s squared. So minus this is 0. So final answer is 1 by s squared. Minus of minus, it will become plus. Therefore, L of t is equal to 1 by s squared. Okay. Next, let us find out L of t power n. There are two methods to find out L of t power n. First, let us see method 1. L of t power n by definition, it is integral 0 to infinity e power minus st into t power n into dt. Or integral 0 to infinity t power n into e power minus st into dt. This is the first function and second function. If you integrate, by definition, if you integrate this t power n first function you write as it is and integrate the second function. So e power minus st by minus s. Okay. Minus this, let us close this, integral 0 to infinity minus of, then integral 0 to infinity, you have to differentiate this one. So n into t power n minus 1, and whatever you have written in this bracket, that is after integration you have written, no, this you write as it is. So e power minus st by minus s into dt. That can be written as, and here if when you substitute e power minus infinity, it will become 0, and when you substitute 0, here you have t power 0, so it will become, 0 power n, that will become 0. So for both the limits it will become 0, and this minus and this minus, it will become plus. And n can be taken outside. You are integrating with respect to t, so n and s are independent of t, so I can take it outside. So e power minus st into t power n minus 1 dt. What is this? N by s into L of, this can be written as L of t power n minus 1. Therefore, L of t power n can be written as n by s. Whatever you have, that power divided by s into L of the previous value, L of n minus t power n minus 1. So what is L of t power n minus 1? This can be written as the power whatever you have, that is n minus 1 divided by s into L of t power the previous value, t power n minus 2. Okay, and so on like this. So I can write L of t power n as n by s into n minus 1 by s into, the next term will be n minus 2 by s, etc. L of 2, let us write L of 2. That is n by s into n minus 1 by s into etc. L of 2 is what? 2 by s into whatever you have, t squared. It is not 2, t squared. So t power 2 by s. So t power whatever you have, that divided by s into L of t power 2 minus 1, which is L of t. Right? So this is equal to n by s into n minus 1 by s into 2 by s into L of t. This is L of 2 minus 1 means L of t power 1. So it is L of t. Right? So L of t is what? In the previous problem we have found out L of t as 1 by s squared. So in the numerator you have n into n minus 1 into etc. So it will become n factorial divided by, how many s values are there? Power n. If it is 1, it is n times, and you have n squared, s squared, so it is n plus 1. Therefore, L of t power n is equal to n factorial by s power n plus 1. Okay. So this is one method. Another method, using gamma functions, we can find out L of t power n. Before that, what is gamma function definition you should know. Gamma of n is equal to integral 0 to infinity e power minus x into x power n minus 1 dx. This you have found out already, you have studied in the previous semester. So gamma of n is equal to this one. And there are some properties of gamma function. So gamma of n plus 1 can be written as n into gamma of n, right, where n greater than 0. Similarly, if you proceed like this, we can write it as gamma of n plus 1 as n factorial. That is, gamma of n is n minus 1 into gamma of n minus 1 and so on. If you write like that, you will end up with 1. So gamma of 1 is equal to 1, therefore this will become n fact. This is one property of gamma function. So if you want to find out gamma L of t power n, so this is method 2 using gamma function. So by definition, it is L of t power n is integral 0 to infinity e power minus st into t power n dt. So this is equal to, now let us substitute st is equal to x. Let st is equal to x implies s into dt is equal to dx, or dt is equal to 1 by s into dx. Okay. When s is equal to 0, when t is equal to 0, x is also 0. When t is equal to infinity, x is also infinity. Therefore, L of t per n is equal to, when you substitute this, integral 0 to infinity e per minus x into t. T is equal to what? This implies t is equal to x by s. So, x by s the whole power n into dx is what? 1 by s into dt is 1 by s into dx. Okay. So, power here x per n, s per n and one more s. So, 1 by s per n plus 1 I can take it outside. So, integral 0 to infinity e per minus x, x per n into dx. This can be written as 1 by s per n plus 1. If I want to use gamma function e per minus x into x per, I can write it as n plus 1 minus 1 into dx. N plus 1 minus 1. This can be written as 1 by s per n plus 1 into gamma of what? If you have n, that is gamma of n. Here you have n plus 1 minus 1. So, gamma of n plus 1. This is equal to 1 by s per n plus 1 into gamma of n plus 1 is, by properties of gamma function, it is n factorial. Therefore, L of t per n is equal to n factorial divided by s per n plus 1. Okay. So, in this class we have studied L of t is equal to 1 by s squared and L of t per n is equal to n factorial divided by s per n plus 1. And we have some more functions, some more standard functions we have to find out, Laplace transform of some more functions. So if you feel that this class is useful, please share it with your friends and give a thumbs up so that it will be useful for others also. Thank you so much for listening.